Welcome to Gunship.
Hi, for those of you who don't know me, my name is Todd Kulick. I am Vice President of Technology at TiVo. We are an international video product solution company. We have partners in Europe, partners in the United States, and we just recently acquired a Polish company which has partners and delivers their technology in Latin America and Asia as well. So we are truly worldwide. And it's a pleasure to be here again at WWX. I was just thinking, the first year I came, I barely understood what a Haxelib was, and that was 2 years ago. And now I'm just hoping to spend the next, let's say, 40 minutes talking to you about a Haxelib that we've been working on at TiVo, that we'd be interested in getting your feedback on, that we encourage you to look at and collaborate with us on. So, here's a quick overview of what I'm planning to cover. I won't belabor this too much. Let's get sort of straight to the meat. So what is the activity Haxelib? So the activity Haxelib is a Haxelib that provides a simple, flexible model for building concurrent libraries and applications in Hex. So you could do this before the activity Haxelib. This isn't new, but we're hoping to make a couple things that we were finding we needed at TiVo easier. So that was our motivation for building this. So what do I mean by simple, flexible, composable? So you can see up here. We wanted our model to be flexible so it didn't lock in the programming idiom or the paradigm that people used when they were doing concurrent development. We hoped to provide a framework that people could use to build other libraries and to make those other libraries therefore more composable, so you could use them together. It's a challenge today to mix certain kinds of Hex libraries and Hex componentry because they have differing expectations about how the platform will work, who's in charge of the outer loop, how threading should work. And we wanted to be sure that the thing we built was still portable and that it would run on a lot of platforms. So that's basically what we've built. It is open source. It's available on GitHub there, if you're interested in looking at it. And we chose the Apache 2.0 license. If you're interested in open source licenses, come talk to me. I'll give you an earful about why we like that one in particular. So next, I guess I'd like to share with you a couple of the use cases that we had in mind when we were thinking about and then eventually designing and implementing our prototype of the activity Haxelib. So the first one is actually sort of the path we walked that led to us starting to look into building this Haxelib. We have a large OpenFL application. Those of you guys who were here last year and saw my talk last year may remember that we've built a 500,000 line OpenFL application that we compile and run on set-top devices. It's our user interface on the TV for our customers. And as when we first converted, we were extremely happy with the performance benefits we got just from switching to OpenFL and switching to use C++ backend so that we could compile code that was previously written in ActionScript. But as we've continued to work on that code, we've had a desire to add additional threads to our application to speed things up. So there's things we'd like to do in parallel. And on our platform, underneath, we're a Linux system, so we have access to fairly rich POSIX multi-threaded APIs. So, as you can see, the first use case was sort of what drove us to begin talking about this. But as we talked about the activity Haxelib more and more, we realized it could be helpful for other things. Like Sven and Rui were telling us this morning, you guys were trying to componentize things. Well, we want to do the same thing. And we want to be able to componentize our software, our large software base, but still be able to build concurrent things and share them and connect them together. But we want them to be modular, so we don't want bad dependencies to creep across the lines. We want the developers to be able to own and encapsulate the important parts of what they're trying to do. Some other examples that may be more game industry focused are, you could imagine taking a very cool multi-threaded physics library and wiring it into your Hex game, or perhaps you have some even more complicated rendering and tessellation system. We think if those kinds of systems were built with the activity library and OpenFL, NME, the toolkits used the activity library, it would be easier to compose these things. And in a general sense, any hex framework that sort of claims the outer loop and control of your application, that provides sort of the metaphor and the infrastructure around, like, within which you program, could potentially benefit by using the activity Haxelib under the covers, because it would allow that system to be a little more flexible. You would be able to compose new components into it. There are a couple other use cases that, as we thought about this more, came up. I know that the room has at least some reactive programmers, functional thinking programmers in it, and oftentimes it's hard to compose functional code with procedural code. And if you want to build big things, sometimes you want to leverage libraries that are written in one way or the other. We haven't actually prototyped this, but we believe it's probably possible with something like the activity Haxelib to build a functional model where you could build libraries that themselves are functional, but then compose them with other bits of code that are not functional. And then finally, it would help in general just building and combining concurrent code across a range of platforms. So I keep saying concurrent. What do I mean by concurrent? So I'll take a step back and explain what I think that means. So when I talk about concurrency, I'm talking about a programming model, not so much the implementation or the instantiation of your code when it's running or delivered to a platform, but more, how do you think about building the functionality that you're trying to build? So when I use the word multi-threaded, I'll generally be talking about the implementation of something or the instantiation of it running on a system. But it's certainly possible to build a library or a program with a concurrent mindset to structure your code using concurrency, and then when you execute it, it could actually be executing single-threaded. So we wanted to keep that use case in mind. So now I'll talk about a couple of the different models we were imagining, because we kind of wanted to do a survey of the models. We wanted this library to be usable by a lot of people, and we didn't want it to lock you in any more than we had to, while still helping you get to all the platforms. So one very simple concurrency model is single-threaded. Everybody knows this one. You have global state, or call it local state, it doesn't really matter. You have state in your program, and you have a thread of execution, exactly one of them, and it runs along, it touches memory. There are a lot of systems built this way, a lot of platforms that hex targets, platforms that people write code sort of targeting natively. It's important in that this is the only way to target certain devices. Like you see I have a star there next to web browser. Yannick Dominguez, who unfortunately isn't here this year, points out to me that JavaScript now even has a worker API or something. I'm not super familiar with it, but interesting. Might leave that model. So another concurrency model is called the actor model. Like maybe people familiar with the actor model, people have programmed with this. So it's a relatively simple concept. It's very clean, which is I think what a lot of its proponents and users like about it. Basically you can have concurrent execution. You can build your code out of separate pieces that can simultaneously execute. And each one of those simultaneous executing contexts has its own state. And the only way they can interact with each other is via message passing. So that sort of prevents any kind of ugly interactions between them. And it's a very clean model. Sometimes it doesn't put all the control in your hands, but you also can't mess yourself up quite as badly or maybe easily in this model. And then finally, there's a model. I had to look up the name of this. I didn't actually know the name of this model. I just know this as like writing multi-threaded code. Apparently, it has names in the literature. It's called either explicit multi-threading or the parallel random access model. And in this concurrency model, how many of you are familiar with like p-threads, POSIX threads, or something like that? Java concurrency. All of those basically use this model. You have a large chunk of global memory, and then you have a bunch of executing contexts, and they can access that memory. And hopefully you make sure they do it in some controlled way, and your program isn't completely non-deterministic and confusing. And there's actually great literature on how to prove that your program isn't non-deterministic and broken, and the literature basically says you can't. So this model is convenient, and a lot of people use it, but it's also very easy to get in trouble using this model. So I'm not going to actually try to explain every concurrency model. I don't know them all. Those are the 3 that I've personally programmed in. There are a lot of other ones. This will be my best reference to go in the presentation, Elliot. I think I have a better guy than you. I mean, he's on the internet, but if you want him, let me know. He's kind of cute. So yeah, coroutines is the model used by Go. There are even more formal sort of mathematical models for building concurrent applications, Petri nets, process algebra, and there are more. If any of you guys have done big data stuff, even like multi-distributed systems like MapReduce, Hadoop, you guys have heard of that, like the Yahoo thing. That's actually another concurrency model. So after we looked for a while, we asked ourselves, well, which model would we like to have? And what limits are we willing to put on the system to be able to get to all the platforms we want, but still give people the options to do sort of as many things as they can. So next I'm going to talk about the conceptual model that underlies our activity Haxelib. So when we went to think about the model, we went back to our early sort of goals and looked at what are we trying to accomplish and what should our design points be. I apologize for this slide. It's a bit of a wall of text. But at a high level, of course, we wanted the library to support multiple flows of control. That was the whole point. It had to do that. We wanted it to support single and multi-threading, both. So it had to, when you built using this model, if you implemented software on it, you had to be able to ship it to single-threaded platforms. We didn't want those to be excluded. Again, we wanted the composition benefits that I talked about previously, and we kind of wanted to hide the details of the outer loop from you if you programmed in this model. So you shouldn't have to worry about that too much. I mean, like it says at the bottom, basically we wanted to let you write concurrent software, whether it was a library or an application, and run it on every platform that you could target with Hex. So we have a very simple conceptual model for the activity Haxelib. There are activities and there are event sources. Activities are a pretty simple concept. They're basically a virtual thread. They're a flow of control, a sequence of steps, code executing in your program. The one difference is they may not be mapped to the same thread or CPU at all times. So they're a virtual concept. They're the idea of a flow of control. And they always run in small quanta and always in response to being told that there's something for them to do. So probably many of you have programmed in an event-based programming model. Flash is one, X Windows, Node.js. That's a very common model. So in our model, we have event sources, and the event sources trigger activities to do things. So activities suggest that they're interested in certain kinds of events, and when those events occur, the event sources notify them, and the activities run. So an activity is just a context of execution, like I said. In this little model here, the green bars are supposed to represent running code in an activity. And the little yellow stars represent event sources. So the event sources are stimulating the activity to do some work based on something happening. And the actual sequence of work done is not controlled so much by the activity as by the events that occur. Now, once an event occurs, an activity may do a sequence of many things, but eventually it will come to rest, and hopefully fairly quickly, and then it'll wait for the next action that it needs to handle. So this is very much, again, Node.js is very much like this. Many other models as well. Another important point about the activities as we conceived of them is that they can actually be executed simultaneously. It's possible, the model says that it should be possible for that to happen. So you have to be aware of that when you write your code, that two separate activities might be running at the same time, if the platform that you're targeting supports that. And again, they should run in small quanta. So here we can see a couple of activities, sometimes running separately, sometimes running overlapped. So let's talk a little bit about the event sources. So event sources are basically the things that make activities do work, as I said, and there are different kinds of them. Basically, there are three large categories of event sources in the system as we imagine it. So the first is sometimes information comes to the program from outside the program. This is reading a socket or a file being ready, a file descriptor in general, or the user hitting a key on a keyboard or a remote or a mouse. Something outside the program causes it to want to take action. The second category is sometimes a program with multiple activities has cases where one activity wants to trigger another one to do work, and we have certain event sources that represent and support that idea as well. And then finally, For completeness, although this might not strictly be necessary, but to keep the model simple, we actually allow activities to trigger work on themselves. So the most common example is maybe the timer. You guys, everybody's probably written code with a timer. We support a timer. So in this picture, I'm showing 4 different activities. And in this case, I'm demonstrating how they might be mapped to a single-threaded platform. So at the top, we see 4 activities, and at the bottom, we see one. I called it a CPU. It could be a thread. It could be the browser JavaScript runtime. The idea is that the activities are interleaved and they take turns or are somehow selected to run on that one resource. And when you program, you're using the activity model, your code will be run like this on single CPU machines. However, if you have a 4 CPU or a multi-threaded system, then your multi-activity code will be able to be mapped to all those separate resources and run separately. Okay, so if that was as clear as mud, it's somewhat clear. Let's talk a little bit about the API. So the first class that you probably would read if you were to go look at this code, not only because it's alphabetically the first one, but it's also probably a good place to start, is the activity class. So the activity class is fairly simple. It doesn't have much API. The most important thing it lets you do is create an activity. So you can see in the sample code here, it's quite simple to create an activity. My activity is calling some function called main activity function, which I'm not showing you because it's incredibly awesome and proprietary, and no, it's just an example. And the activity class also provides the API that lets you start the system and shut down the system. So here, I demonstrate starting the system. It's very easy, activity.run. I'm not showing the shutdown case, but it's relatively straightforward as well. I'll point out that it does have well-defined semantics about what happens when you shut down. If you still have lots of activities running, if you have event sources alive, if they're registered to each other, the documentation explains how those things work. So if this is the activity API, maybe the next thing to discuss is the event sources. So I'll start with the timer. So a timer is a very simple event source. It's one of the ways, as I mentioned previously, that an activity can trigger itself to do work. The timer class we've created supports repeating. So if you want, you can be triggered every 10 seconds or something like that. And in the example here, you can see in the first green bar, the activity code is running, and it registers itself against this event source, maybe creating it. And then you can see subsequently, the event source is causing it to run more code. So the timer is triggering. Some amount of time has passed, and then some amount of code runs. And here's a little sample code that would do something like that. The top example demonstrates we actually support 2 modes for creating timers, and one of them is what we call the explicit mode. So you can see here we're constructing a timer object, setting some values on it, setting it repeating, telling it to fire every 10 seconds, and then registering the function that gets called back in the activity when that timer is triggered. The second example shows we also support this sort of syntactic sugar method. There's no real reason to construct an object in this case, potentially. So there's a simpler version where you can just say, timer once, do this thing after 10 seconds. We support another kind of event source that's useful for triggering work back within the same activity. We call this one a call me. I bet you can't guess what it does. It calls you. Which maybe call myself, I don't know. And again, it supports the syntactic sugar in the same way. This is kind of like having a zero-length timer. Just like, curious, how many people have implemented the zero-length timer? That's awesome, right? Best idiom ever. So why is this different? Well, one thing we did differently here is it has a very small number, a fixed number of priorities, and it's actually a priority queue, which can be useful if you want to do any kind of event collapsing or other things like that. Okay, so those are the 2 very basic event sources that activities can use to trigger themselves. We also have support for activities triggering other activities. And the way they do this is with, well, there's 2. I'll talk first about the notification queue. So the notification queue is another kind of event source that once constructed, any activity can poke the notification queue. And one of the people listening to it, one of the activities that's monitoring it, will be woken up to do work. So here we can see an example of activity 1, waking activity 2. And again, this example is simple. It shows one writer, if you will, or poker, and one pokey. But the actual event source supports letting multiple people be either readers or writers. So the obvious extension of this is if you want to send some information along when you poke someone, so maybe this is the more common metaphor, we also support a message queue. And here you can see a message queue between, again, this, let's say the same two activities, 1 and 2. And activity 1 is sending type T objects to activity 2 to do some work. Okay, so now let's talk about messages that come out from outside the program. So the most common way that, well, I'm going to say we, in the code we've been implementing, have messages arrive into our programs from the outside is via the network, via socket. The socket event source is quite simple. You listen to it when bytes are ready, or for reading or for writing. Actually, it supports like blocking in both ways. It actually supports all the TCP modalities if you care about such things, passive sockets and accept and listen and all this business. But fundamentally quite simple. Something happened outside your program runs code. We also support a UDP socket and a web socket. The reason, well, the notable thing about WebSocket is it's an event source metaphor that we can actually deliver on every platform. The TCP socket is not available in a place like JavaScript. You can't do that. So if you want to build a program, if you have to use UDP or TCP, we've made them available. But if you want, and you're doing something much simpler like HTTP loads or something, you could use the WebSocket. If we wanted, we could go one level higher, and on top of this, we could build a new event source that's like an HTTP loader, et cetera, et cetera. Okay, so I'm talking about the model we chose here, right? Two simple things, activities and event sources, and I just walked you through a handful of them we have. So I submit to you that with that model, we can build actor model style programs, right? So for those of you who've done actor models, all this probably seems like obvious and familiar, right? So the question is, what if we don't want to restrict people to the actor model? Can we give them a little more functionality, some other API, that might allow them to use a different model if they want? I'm not saying this is a bad model. This is actually quite a nice model. You could use it if you want. We just don't want you to be locked into it. So it turns out if we add one more concept, if we add something like a mutex that can be used to lock or exclusively block threads from entering, or I shouldn't say threads, activities from entering the same region of code, then you can actually build applications using a global state model where they share information globally. So we actually have a mutex class as well. And this class works just fine on multi-threaded and single-threaded platforms. You might ask, what's the point of a mutex on a single-threaded platform? Or I asked. It has no point. But if you want to build your code for our concurrency model and you use it, then your application will run on multi-threaded platforms the way you expect. And on single-threaded platforms, the mutexes are just no ops. They don't need to do anything, and they don't. The one trick is you have to let go of the mutexes before you return from the callbacks. Otherwise, you could deadlock. Do you want to do it now or at the end? Come on, let's do it.
I just wanted to ask,
I'll repeat it. I can repeat them.
on single-threaded platforms, when you have multiple activities, the mutex is still enough?
On single-threaded, the question is, on a single-threaded platform where you have multiple activities, is the mutex still a no-op? And my answer is in the current implementation, maybe you're going to teach us something. This is great. We're collaborating, and we'll decide to change it. But in the current implementation, yes, it is. So again, back to my The model is you can use any resource you'd like in an activity, but you have to stop using it. It has to be ready for someone else's use by the time you exit your callback. So we run each callback to completion, and the model is you should use a mutex. That's the one where it's simple, and you should use it to represent another resource if you had a different resource, just for simplicity. But there's really no reason we couldn't add some other kind of resource that you needed to lock. So adding mutex now, we have the ability to support both the actor model and the parallel random access model, which is getting us close to what we wanted. We can still hit single-threaded, multi-threaded platforms. The code is portable because it's in Haxe, and we can hit a lot of platforms because we support these different paradigms. And there's a single common API, so you don't have to write a lot of if-defs. You just write your code one way using this metaphor, and then it can work in other places. And it can be composed with other code that honors these rules. So we also have a helper class. There could be more. There probably should be more. We're happy to discuss this with anyone who wants to collaborate. Send us pull requests, emails. The worker pool is a simple concept. It's built on top of all the other code. It wouldn't really have to be in the activity Haxelib at all. It could be a separate thing. But it's provided for convenience because it's a commonly used idiom. So, wrapping up. Who might find this useful? So I offer that it might be useful to people building toolkits. It could be interesting to imagine if the toolkits were built on this at the bottom, or if the bottoms of the toolkits were somehow refactored to be part of this, which is also an interesting possibility. That would allow people who program in these toolkits to bring multi-threaded concurrent libraries to the toolkit without having to change the toolkit's main loop, its outer loop, and dig around in the native code that exists in most of these. Also, if you yourself are trying to build a Haxelib and you want to build some incredible functionality and give it away to the world, to the rest of the Haxe community, and you want it to do awesome concurrent things on the platforms where that capability is present, if you use this library, you would get that benefit. And finally, maybe you're just writing an end-user program, an application of some kind, and you'd like to use concurrent metaphor. You could use the activity Haxelib for that as well. So there are a handful of things that we would love to do following up. There's additional common helper classes that we think should probably just be included. The current implementation is all native Haxe code. All Haxe code, no native code. It has if-defs, of course, but it could be that faster implementations could be delivered in native. We believe that we could implement that if we wanted and wouldn't need to change the API. So that, in theory, we could even support both if that was useful. And we'll probably look at that going forward. As I mentioned before, we haven't really looked into the JavaScript browser support for the worker API. In theory, we could try to imagine some way to use that so that we would provide some kinds of concurrency on browser environments. It's a little tricky because I believe the worker metaphor is more like the actor model. There's no shared state. You can only pass information in and out of the workers. So we might have to disallow some models if you use that. And we're actually looking to port some of the low-level toolkit that's under our user interface to support this so that we can do some of the work I mentioned at the beginning in the use case sections. And finally, I'll be around the whole weekend. I would love to hear any of you guys' ideas. I guess on that note, listening this morning, this sort of topic kept coming up. I don't know if you guys know this XKCD. It's like one of my favorites. I submit to you all that as a group, as a collective, as a team, as the smarts of Haxe right here in this room, we should try to not let this happen so much anymore. It's happening like on 15 dimensions, and all the people in this room are really amazing, smart, interesting people that are fun to collaborate with, at least the ones I've collaborated with. Talk to each other, and let's see if we can't get some more of this stuff overlapping so that we can share our great practices. Whether it's the IDE, we should work together as best we can if we can figure that out, or it's the build tools, or it's the application frameworks. There's probably lots of opportunities for us if we grab them. And finally, I would be completely remiss if I didn't mention these two gentlemen. Brian Ishko is the designer and implementer of this entire API. Certainly others of us have talked with him about it, and it represents ideas from a few of us, but this is Brian's creation. And if you have questions, I mean, I'm happy to try to answer them. I've read the code. It's not a large amount of code, but Brian, I'm sure, would be happy to answer them as well if you follow up with him. And Yannick also helped build a bunch of the very excellent tests that are in the test suite that helped us feel reasonably confident that it worked right. So I think that's my presentation. I'd be happy to take any questions if people have them. So anyone other than Nicholas? Oh, that's rough. That is rough. I like it.
This is a very interesting talk for us, actually, because in our company, we actually have something quite similar. I mean, we call them tasks instead of activities, but yeah, whatever.
That makes no sense. You should switch to ours.
No, we should define a new name for, no, whatever.
Yeah, exactly. Tasktivities.
Yeah, anyway, actually, when we started it out, it wasn't, the objective was not so much to get things done faster. It was mostly about being able to render at 60 frames while doing complex stuff. So basically, if you have a list of stuff that you need to do, you set it up in a sequence of activities, and then those get executed whenever the frames allow you to. So in order to keep the loading and stuff. So I was wondering if you have something like that. Basically, I'm sure there must be some kind of run loop, or you must build this on top of something that's...
Some kind of run loop. Well, so first of all, I understand your goal, I think, there. Certainly we have a similar goal with some of the things we've built. If I were to interpret what I think I heard you say, you didn't even maybe do it to go faster. You did it so that you had a simpler programming model. So you could separate the concerns of what you were trying to accomplish on the rendering side from handling user input or network or whatever. We certainly have the same requirement. Today we're built on top of the Flash API. The Flash API is fundamental, like it thinks of itself. It proposes to be a single-threaded environment. It doesn't really make an affordance for doing anything else. That said, the player that's under that environment could certainly be doing things in parallel. It could be decoding your images for you off screen, and in theory, it could be downloading things for you if you use the right parts of the API. It actually has parts of the API that work both ways. But yeah, I mean, we're certainly thinking about use cases like that. We would hope to be able to support use cases like that. I mean, so, and I would love to share, both of our code is open source. We should both look at each other's and talk.
And I can show you, and we can talk.
Yeah, I would love.
Another thing is, because in C++ right now, in HaxCPP, the multi-threading, the garbage collector is not really concurrent. So basically, if any of the threads wants to collect, then everything stops.
That's right.
So I was wondering if you somehow had solved this.
No.
Okay.
That's, I mean, let me go one step further. Every allocation is cannot be parallelized, right? Effectively, you have to put a mutex every time you want to do an alloc. You can imagine smarter out, like multi-zone GC and all that. I mean, there's lots of research on this, of course. We're not doing anything like that yet. Okay. I think, some of this is, endemic sounds like the wrong word, but endemic to the language. I mean, the features imply that things will work a certain way with garbage collection and allocation in Hex. So it could be a challenge to figure out how we do that. But there's a lot of literature, I think.
Okay, thanks.
Nope.
Two questions, actually. First one is technical. For the mutex, how do you ensure, how do you react to deadlocks?
Well,
for instance, if activity A acquire resource 1 and want resource 2, and activity B have resource 2 and want resource 1.
Right. So this is going to sound like a complete dodge. But first I'm going to answer this from the perspective of the library, and then I'll tell you what we do when we use this kind of infrastructure. The answer from the perspective of the library is, you said you wanted to use the parallel random access model, and you didn't think about your synchronization enough. How does it react to deadlocks? It deadlocks. I guess that's what it's supposed to do, right? So you chose that. If you choose that model and you're not careful. Now, so we use that model not just in Hex, but in a lot of code at TiVo. And what we normally try to do is, I think what's a fairly standard strategy, it's called lock ordering. So the idea behind lock ordering, if you guys haven't heard of this, is just you take every mutex in your system and you give it a number. And then anybody who ever wants to have more than one of them, you have to acquire them in order. like by their numbering, either up or down, it doesn't really matter. But because the problem normally comes if, you know, guy A gets lock 1 and guy B gets lock 2, and then they both want the other guy's lock, and now you're done. But if everybody goes in the same order, you can guarantee that won't happen. And in fact, it's also very easy to write an audit in your code that if anybody ever tries to grab a lock with a higher or lower number, whichever way you're doing it, that's broken. Like that code is broken right there, and it's very easy to find. So that's the trick we use. We haven't really considered building that in. We could do that. I mean, that could be an interesting addition to the API. The trick is really numbering all the locks. Yeah. I mean, it's simple to add it to the API and make the users make up all the numbers, but then they can, yeah, then they have the problem. You've kind of kicked it.
Okay. Second question is about, because I find it very neat, and I think it really answers a lot of, you know, Where's problem, like reinventing the world people do in every library. So
cool.
Do you think it would be a good idea to have this or modified version in the standard library of Haxe to kind of ensure that the success of the standard, or would like to contribute it? Are you interested in that? Do you think, or is it still early or something?
So to be perfectly honest, like we didn't start talking about this because if we were just going to use it at TiVo, it honestly has very little value to us. Like, we could just do it. We could just design this, and we could use it, and that's great. I think the real value of this comes when somebody else outside of TiVo writes a really great library that we could benefit from, and it uses this framework so we can mix it into our Flash application or something like that, which today is very hard. Today, it's just, there are certain bits of, like, hex technology you can just, you can't smash them together. Like, they just will not go together. So if somebody wanted to work on this, if anyone was interested, we would welcome it. Either, like, fiddling around with the inside bits or building stuff on top of it, both. Our whole goal was to make it available for people to play with.
Yeah, because sometimes we are considering when we choose bits to include in the Haxe standard library, sometimes it's good to have it there because it's more standard, and then people rely on it and don't go on Haxelib to look for a library, and there's several of them. So it makes higher chance that it becomes like de facto standard. But on the other hand, it means suddenly we have to maintain this code, and that's become much more. Yeah. So you have to find some kind of way to decide.
I mean, I guess I'm sort of dodging your question a little, but I guess what I'm saying is if people play with it and they think it's useful and they think it should be in the standard, we wouldn't have a problem with that. I don't think it's made, like, I think more eyes should be on it before a decision like that was made, honestly. Like, not because I think it's half-baked or terrible. I think it's pretty good. I think we've thought through the options and we kept the parts we needed to keep to target platforms. So I would love to see adoption if that would help, but I also, you know, I'd love to hear people's, you know, criticisms as well, negative feedback.
Yeah, just a comment on the standard library aspect. I think it would become more useful once, if the standard library, say the stock part of the standard library, then was activity-based. We're having issues at the moment about you know, is this socket blocking, is it not blocking, and then, you know, the whole kind of concepts there. So I think if you put it in the standard library, then to actually change all the other asynchronous aspects to also then use it, then it will become super powerful or something like this. And that was my comment. And a question, do you have anything to do with like thread affinities? Like for OpenGL, say, you need to be running the everything on the right thread.
I think it would be easy to add like affinities. Certainly, again, this is a thing we do a lot of on our devices, since they're Linux boxes, our set-top devices. I don't think it would be hard to add. The question is, if the API presents support for affinities or thread prioritization, but can't honor it on some platform, will it break the program? So I think the question you need to ask yourself is, if you're offering up this metaphor for development, if you can't deliver the metaphor fully, what kind of guarantees are left? And I think you saw, I already stumbled across some things where I said, well, we might add this even though we can't perfectly honor it. I think that's very much in the spirit of how lots of Hex and Hex libraries work. It's like, we do the best we can for you, and we hit as many things as we can. If you do it this way, we go everywhere. If you do it this way, you get 3. So I think that could be added. It's only appropriate probably on certain platforms, right? But maybe some very important ones.
Anything that uses, say, OpenGL is going to need to be running on the same thread, right? So
Yeah. Yeah. I mean, again, back to this idea of modularizing code, I think part of why we wanted to do this, I don't see this as like the end game. This is just the start. Like, I loved hearing what you guys are doing at Game Duel, because this is exactly the way I think about where I want our software to go over time. Today we're built on this monolithic toolkit and the system library, and everything comes preloaded in there. But if I want something else, like if I want my own side way to do video and I need to control resources and operate at a low level, there's no affordance in the Flash metaphor for that. And I have to sort of go rogue. But if we started to break these things into smaller pieces, like NME could be a graphics piece and an audio piece and an input piece, all built on top of a concurrency model, it might be easier to mix and match. And that's where I'd like to get to eventually for our stuff. Uri wants to beat me up about something. No, it's fine. Let's make him wait.
How do you handle thread synchronization? For instance, if you run background thread that has to provide a result on a specific thread?
Are you talking about with native code?
Yeah, for instance, you want to load an asset in the background and then to decode it, and at the very end you want to get like a bitmap on the UI thread, right. So you can push it on screen.
I think the basic proposal would be to use something like this thing, where one activity is doing the decoding work, and when it's done, it presents the result to the other activity, either as a pointer in memory or like a reference to some object by ID in a map, or passing the object itself. This is all assuming that all the work you're talking about doing is in Hex. If you're in native, then you've already made some decisions about what platform you're on, and there are implications that come along with that. I think the rules don't really change much, but they're complicated and they're different for each platform. Am I answering the question?
Yeah, I guess so. I guess the sender also has to be an activity and a receiver of events, so you have to decouple that.
That's right.
And send a message and somehow get the result from another stream.
That's right. I mean, using the mutex, it's actually possible. I don't know if I mentioned this, but it's possible to have one program that's partially actor model and then another sort of realm of the program that's implemented in the prem model or the explicit multi-threading model. You just have to be very clear about crossing the boundary. This is really common when you're using that prem model. You have to, there's libraries that you want to use that were written for single-threaded, and you just have to make sure you never have 2 of your 57 threads simultaneously go in there or something, or you always like shuttle the work off to one thread whose job it is to do that. And I think all those sort of standard patterns could still work. I think so.
So you could, like for instance, start an activity and providing a reference to your message queue. So you would get a reference pushed into that.
Yeah, I mean, if you're using the actor model kind of concurrency style with this API, in fact, every time you create an activity, you'll give it, like in a controlled way, all of its event sources generally, except the ones that it's going to use to trigger itself. Those can be sort of like local, private things. But all the other things you would think of as inputs. And I didn't really show you code for the queues, but the way the queues actually work is there's a queue object, and when you construct it, it has 2 ends. It has like the input side and the output side, and those are objects inside the queue that you can extract. So I can construct a queue and give you the output side, and I can give the input side to somebody else, like Sven, and he could write into it and give you objects. You guys have when you wrote your code, you had no idea except the object passing through there what it would be.
Yeah, so when the message queue treats the inputs, it will run that in the UI thread, let's say. Are we sure that it's going to be in the UI thread?
Yeah, I mean, maybe we should talk afterwards, but I think you guys have some specific use case in mind that maybe I'm not guessing, but we could try it. You gonna let Uri try, or?
Okay. Yeah, I was wondering, what's the schedule on moving the library forward? Because you like kind of published it, and there's a whole lot missing.
You're awful. You're awful. You were
No,
just looking, weren't you?
to-
You're just there looking at all the commits, and you're like, come on, man, it's been since April. That's because it's done. That's what done looks like.
No, but there's like, for example, the socket fast select thing isn't there. There's no multi-threaded implementation. You know, I mean, there's a lot of stuff.
Actually, yes, I understand. So the version on GitHub is not as new as the version sitting on Brian's machine. And, you know, I'll poke him when I get back to Silicon Valley and get the latest version uploaded. I think he was working on it this week, actually. But yes, we actually have some additional changes that haven't
gone in. It's just a matter of pushing, so to speak, more or less.
Yeah, if you send him an email, let me know. I'll give you his email.
I will. All right.
Awesome. That means you want to use it. That's great. Yeah, cool.
Last one.
You talked about sort of bootstrapping this into Lime and OpenFL. What about simpler programs, like just starting to play with this in Nico? Is the process of actually opting into this run loop simple? Is it just like, here's my main entry point?
Yeah, I think since it's a pure hex implementation, it just works on Nico now. Like if you write that code right there, and then if you replace my incredibly awesome main activity function with your own, you're good to go. I didn't talk about this a lot, but or at all, but that create API can be called by other activities. So one very common thing to do is like one activity creates another one, or it creates one for a while and then it goes away. And if you read the code, which includes very, very good Java docs, Brian's like a stickler for that, and they're quite good. It describes like how shutdown works and all that stuff. So yeah, you could write like a command line style program, whether it's Nico or you're targeting C++ or whatever. That should just work. All the tests run that way today.
We have a very last question, but this one is the true last question.
Have you benchmarked the overhead of using such a system in a normal program that is targeting a single-threaded target?
Have we benchmarked? No. I think the answer is no, for sure. But I expect it would depend very much on your program. So if you had a program that you're going to write single-threaded and you chose to write with a concurrent model, like the actor model, it could be slower. It depends a lot on what events you create and how you pass them around and how they get scheduled out on the system. I think for now we're interested in what people think of the metaphor. Like, is this API, is the structure right? Because the structure helps us get to a lot of platforms. The actual implementation on the platforms could be tuned, of course. But yeah, I think there's a whole class of programs for which the device they're running on is more than fast enough. I mean, it's 2015, right? Almost everything's just like, computers are just fast enough. Not on set-top boxes where we work a lot of the time, but
okay,
yeah.
Cool, thank you.
Okay, thanks. All right, thank you very much.
Welcome to Gunship.